10-minute series. In last lecture we saw the equation V is equal to Ki, where K is the permeability, I is the hydraulic gradient. So basically coefficient of permeability, it we know that it is having a unit of velocity. Okay, so if we want to define, we can write the velocity of flow, which will occur through the total cross-sectional area of the soil. Or aquifer also, under a unit hydraulic gradient. Unit hydraulic gradient means when the value of hydraulic gradient becomes unit means 1. So the value of I becomes 1. At that point V is equal to K. Velocity will become equal to permeability. Okay, so we can write this equation V is equal to Ki, or we know that we have seen Q is equal to KIA. That formula also we have seen. So basically now I will be writing some of the important assumptions of Darcy's law. So this you will find in the chapter of permeability in geotechnical engineering. So the first is the soil is saturated. Second is the flow of water basically. So the flow through soil is laminar. Laminar means viscous flow. Okay, both are same thing, viscous. Then the flow is continuous and steady. The total cross section area of soil mass is considered. Okay, so whatever, suppose this is the soil mass, so you have to consider the total cross section area. Okay, suppose this is B and this is D. So B into D, this is total cross section area you have to consider. Okay, because actual cross section area will be different. Actual cross section area will be less, I told you, because there will be soil solids. So water cannot pass through this soil solids. Okay, so water has to pass through the pores. So all these voids will be interconnected. So the ultimate net cross section area will be less. So basically the seepage velocity we have studied, Vs is equal to V by N. So this actual velocity will be more. Okay, so fourth point is total cross section area of soil mass is considered. And last, the temperature I am writing here, the temperature at the time of testing is 27 degree centigrade. Okay, so this was the definition, assumptions of Darcy's law. And another concept related to again soil mechanics only. Whenever you are having some concentrated load, so whenever you are having some concentrated load and you have to find the stress at some distance. Suppose this is a distance, this is your ground level, okay, and suppose one concentrated force is Q and this is distance Z. So whenever you want to find the distance stress due to single concentrated force, so here suppose this is the radial distance R. So suppose at this point, then we can find out by using a formula sigma Z. Sigma Z is equal to 3 by 2 pi Q by Z square upon 3 by 2 pi Q by Z square into 1 upon 1 plus R by Z whole square whole raised to 5 by 2. Okay, so you know what is R. R is basically radial distance, and Z is the perpendicular distance exactly below the point load. Okay, so by using this formula is for single concentrated force, okay. So if this is the case, one point load single force is there, so we can apply this formula and we can find out the stress at any distance, any vertical distance as well as any radial distance, because we have the value of Z and this is the radial distance. From this point we can find out either right direction or left direction. So this is R. So at any point we can find out the stress. So basically it is vertical pressure. So same way, vertical pressure under a uniformly loaded circular area. So if the area is like this, circular area, okay, so there will be some radius, okay. So here the formula will be sigma Z is equal to Q 1 minus Z cube. Z cube is your perpendicular distance directly below the load upon A square plus Z square raised to 3 by 2. Okay, so here in this formula A square or R, both are same thing, we can write A also. Okay, so this is notation given in books, so it is written A, so we can write down A. Even we have one different formula. Suppose the value of A is not given, sigma Z is equal to, we can write directly Q 1 minus cos cube theta. Many times they are giving the they are not giving radius, they are giving the angle. Okay, so we can apply this formula also. So what is Q? Q is basically net intensity of pressure. Okay, remember this is net intensity of pressure. It is totally different from gross intensity of pressure, so don't get confused. Okay, so thank you very much.